Introducing the latest RADEC pyrolyser system, the Pyrolyser Generation 4. This instrument has been purpose-designed for the extraction of volatile radionuclides from a wide range of sample types. These include samples for waste characterization through to samples for environmental monitoring. The pyrolyser's effectiveness is underpinned by more than 20 years of extensive testing and published scientific research. The fourth-generation pyrolyser employs an intuitive HMI-PLC user interface, allowing easy programming of the fully independent three-zone furnace system. Extraction runs can be controlled via one of 20 user-definable programs, along with automated gas control, thermal ramping, and data logging. The pyrolyser furnaces can extract tritium and carbon-14, as well as other volatile radionuclides from up to 6 samples simultaneously, with the runtime dependent on sample type and sample mass. The Pyrolyser 4 weighs 120 kilograms, so take care when lifting. Ensure that a pallet truck or trolley is available to transport the pyrolyser to the laboratory and when positioning it into its final working location. The Pyrolyser 4 requires suitable clearances within its chosen site. On the left of the system, allow approximately 1.3 meters for easy loading and removal of work tubes. On the right of the system, a dedicated space of 1 meter is recommended for the sample bubblers. An air gap of at least 10 centimeters is recommended behind the pyrolyser and a headroom of 50 centimeters. Although pyrolyser heat emanation is modest, a general air extraction system is recommended above the system. In addition, a local bubbler extraction box is available to remove any solvent fumes emitted from bubbler traps. The Pyrolyser 4 is supplied with a range of accessories and consumables required for initial setup of the system. The system has a convenient service drawer, providing ease of construction and maintenance by authorized personnel. The latest Pyrolyser 4 can be connected to 3 carrier gas supplies. Oxygen, air, and optional nitrogen are connected to the system on the right side of the machine. The flow of each gas is controlled individually and distributed through an internal manifold to the work tubes. The Pyrolyser-6 Trio instrument accommodates 6 silica work tubes. On the left-hand end, an end cap with a gas feed connection is attached to the work tube during a run and held in place with a PTFE clip. On the right-hand end of the tube is the catalyst zone, holding a replaceable catalyst pellet bed. A plug of silica wool is positioned at the end of the catalyst zone. It is important not to use any other material which might risk damage to the work tube. 10 grams of catalyst can be introduced before a second plug of silica wool is pushed in to hold it in place. The catalyst is typically replaced after 20 combustion runs. Each tube holds a single quartz glass sample boat. A chosen sample is added to the sample boat. Up to 20 grams of solid material can be loaded, the actual mass depending on the combustibility and density of the sample. Typically, the work tube is inserted into each of 6 silica liners in the pyrolyser before inserting the sample boat. The sample boat is positioned in the correct area of the work tube using the supplied titanium loading tool. The carrier gas line is connected to the end cap. Carrier gases transport the volatile decomposition products through the catalyst to the collection bubblers. The work tubes usually remain in the pyrolyser unless they require servicing. The Pyrolyser 4 comprises 3 independently controlled furnace zones: a sample zone, a catalyst zone, and a mid-transitional zone. 6 pre-installed silica liners pass through these 3 zones to support the work tubes. The new touch panel interface screen allows the user to both control the system and to visualize the progress of the current combustion cycle. The analyst selects a desired program, and the run begins simultaneously for all loaded work tubes. The catalyst zone and mid-zone are typically preheated to 500 degrees C and 800 degrees C respectively before any heat is applied to the sample zone. This ensures efficient thermal oxidation of the liberated organic vapors. Gas flows to all tubes are automatically activated, and the sample zone heated according to the selected heating profile. Between 100 and 200 degrees C, water and some volatile species are liberated. By 200 degrees C, liberation of weakly bound tritium is mostly complete. Between 200 and 400 degrees C, more strongly bound tritium is liberated, and carbon compounds slowly volatilize and are carried through the catalyst bed to the external traps. In most cases, when the sample zone reaches 500 degrees C, the airflow is automatically changed to oxygen to ensure complete oxidation of the sample. The sample zone is now ramped to 900 degrees C to ensure the continued oxidation and opening out of refractory materials. All combustion products liberated over the temperature range 50 to 900 degrees Celsius are fully oxidized after passing through the platinum alumina catalyst bed. By 900 degrees C, all tritium and carbon-14 will have been liberated and transferred to the external traps. These oxidized products, tritiated water and carbon-14 labeled carbon dioxide, collect in their own external bubbler traps. At the end of a run, the analyst can choose to rapidly cool the sample and mid-zones by using the integrated forced air fan cooling system. The traps will work at ambient lab temperature, but to optimize the efficient collection of nuclides, the bubbler traps can also be cooled. This can be done variously with a simple ice tray, a thermoelectric cold plate, or for the best performance, a special cryo cooler. The trapping media containing the analytes of interest are subsampled and prepared for tritium, carbon-14 or other volatile element measurement. The resulting output data are used to calculate the radionuclide activities in the original sample. Proven and tested technology in a robust, reliable design, evolved through many years of rigorous research and publication. Totally independent control of all furnace zones. The intuitive touchscreen allows for easy setup of heating programs. Effective and reproducible extraction capability, reducing analyst time and increasing laboratory throughput. Simultaneous extraction of volatile radionuclides from up to 6 samples. Ideally suited to waste characterization and environmental applications. Adaptable for radionuclide speciation investigations, providing insights into modes of tritium contamination. For further information on the innovative Pyrolyser range of extraction furnaces, please contact us at sales@radec.com.